Good morning. Today's lesson is CT14, a reminder about one-dimensional data structures, so 1D lists, and how to manipulate them so that we can use data effectively. We want to understand the characteristics of one-dimensional lists, how we can use one effectively, how we can iterate through one, and discuss efficiency in our algorithms. So a one-dimensional data structure means we just have one index, one position within that data structure. So you can refer to it as an array, but it's not the same as a list. At A level, we look at the differences. Basically, an array must only have one particular data type. In Python, you can store both integers and strings in the same list, so it's not an array. An array can only have the same data type. There we go. In this Edexcel GCSE, you're only ever expected to have the same data type in, so a list of strings or a list of integers or a list of booleans. We have a single index. Think of that like a single coordinate, like x moving across. A two-dimensional array or a two-dimensional list might have a grid, like a picture of pixels moving in x and y. We're only interested in a one-dimensional list today. So how can that work? There's only one item of data per entity. What on earth does that mean? It means it's probably best if we have a look at an example. Okay, so we're used to a single value being stored in a single variable. If you want to store multiple values, you wrap them up in square brackets, and you can have a list of multiple values. What this means of, where's it gone? Here we go. Only a single value per entity. Where's it gone? You have just one number in here to access one value. So names 0 means the first one, and you're used to the idea of you can have a negative number which works from the other direction, or in this case it's the same because this is at position 1, although it's the second value. What we need to be able to do is traverse and search. So that means iterating through a list. So we could have a while loop or a for loop. But we could go backwards, possibly. So we can see an example here. So I think it's better shown with an example than the PowerPoint. I don't really like this. Let's have another name. Let's have Harry. So we've got different ways of doing this. You could just have for name in names, which works. We've iterated through them, but we can only go forwards. Alternatively, we could have for I in range, and we want to go from 0, 1, and 2. So we can say from range between 0 and just less than 3. We don't know what name is, so let's find out what name is. We'll say names at position I. So that's basically how you can iterate through in a slightly different way by keeping track of the position, the count, the index. We rarely put an actual number in here because if we put me in the list, I've forgotten to increase this so that we go from 0, 1, 2, and 3. So what would be much better and what you often see is the length of the list so that it counts up how many items are in that list. We find the length of it. We have a range which will go from 0 up to just less than that value, and then we iterate through each of them. And remember, in range, you can start at that value, go down to 0 in a negative way, although I've forgotten the syntax for it, which is rather embarrassing. You can say the end of the list, beginning of list, minus 1. I'm sure that's what I've got here. Oh, I have to do len minus 1. There we go. So we start at the end. We want to stop just before minus 1, and we want to decrease by 1. So this means that we can iterate through in any direction, or we could skip 1 each time if you wanted, or you could skip 2 each time if you wanted, or you could stop at the second just before the last one. You can control exactly what you want to do. Okay, so I would start with activity 1 on CT14. This is half term 9. 4 characteristics of one-dimensional data structures. I'll leave the PowerPoint up on my screen. If you're working from home, you'll have the PowerPoint shared with you as well. So one-dimensional data structure is a list or an array. Every item in the list is the same data type. We just have one index to be able to access it. Remember, the index is the value inside the square bracket. And in Python, we use a list to implement an array. Okay, so as we start looking at activity 2, we want to think if you can work out if this is suitable to be stored in an array, in a list or not. I would say the first one could be quite happily stored, because you could end up with something like scores equals and then 1, 2, 3. You could quite happily do that. Data for an inventory, ID, description, cost of the products in a tuck shop. Well, probably not if they are different data types. You could do it in Python. You could have, like, the ID might be a number, the description might be chocolate bar, and the cost might be a real value like £1.23. That would work in Python, but it wouldn't be an array, because they are all different data types. The only way you could do it is if you forced them all to be strings. So it would be possible, but it wouldn't be all that suitable. There'd be better ways to store all of those. So I'll let you work through and justify, do you think it would be appropriate to use a list? Remember, we're using a one-dimensional data structure, an array. They all have to be the same data type. Briefly, let's have a look at activity 3. So we've got some code for forward traversal. That means we're moving forwards through a list, and then reverse traversal. We're going backwards through a list. Let's have a look and see what this code looks like. So we have a one-dimensional structure. Although it's on multiple lines, we've only got one set of square brackets. It's a 1D list. We've got a subprogram in here somewhere with an error in. It's asking us for a for loop to traverse it. So you have to make sure your indentation is perfect. It should be lined up with index. You need to choose a variable to keep track. You need to work out what your index is going to be. It looks like should be called index. And then we probably want to use range. Remember, range goes from 0 up to the value of the parameter. So for index in range, the length of in list is what I do, but I'm not going to leave that up on screen. Reverse traversal is going to be similar, but you need to go backwards. If you're not sure what to do here, remember you've got the PLS on the VLE, which gives you a reminder of this, the syntax for both range and for. The bit that you need is when you do range, that's the starting number, that's the stop number, and that's the step number. So if you want to go from 10 to 100, counting up in twos, that's what you do. If you want to go from 100 down to 15, counting down in fives, that's what you do. Okay, so use that PLS as a reference. Remember, in the exam, you get given a printed version. You might get given a digital version. I'm not quite sure. You did in your Year 10 mock. I don't know if you will for the final thing. Okay, so we're going to go through activity 4 together. The idea is we need to do something very similar to what we did for activity 3. I'm aware I didn't record that, so we'll go through the reverse traversal. And we're making it a search rather than just traverse, which means we can stop looking as soon as we find what we're looking for. Okay, so what happens at the moment? What we want to do is search through this list, which is this list, try and find this value, and then if we find it, we can stop looking. So we don't have any errors at the moment, but it says it can't be found. Well, 636 is in that list. The subprogram is called reverse search, so we want to start from the end and go backwards each time. And then when we get to what we want, we should stop looking. You can do this with a for loop or a while loop. Let's have a look at both. If we do a for loop, we can say for index, that's the thing we're going to use for counting, in range. So this is going to set up an iterable thing, like a list that we can loop through from 0 up to a number. or from a number down to 0, or whatever we want. So if we want to go from the last one, we need to count how many items are in my list. Sorry, that's the global variable. We want to use the parameter, so in list. But that will be too big. It'll be trying to look beyond that value, so we need to do -1 to say we want to look at the end value. Then we want to keep going backwards until we get just before this value. So this will say stop just before we get to 0 there, so it won't look at the last one. So we need to put a -1 in here so it does actually look at that first one at index 0. The third parameter here is what do we change it by? So that means go back by 2 each time. That means go back by 1 each time. And then I guess we want to see if we can find it. So found equals, you could do it that way, let's see, if in list square brackets index is equal to what we're looking for, that's the second parameter passed in target, then found is true. So this will work, but it's not efficient yet. Because as soon as you find what you're looking for, we don't need to continue looking. So there's a couple of things you could do. You could say break to break out of the for loop, but that's considered bad practice. You should avoid that if at all possible. Alternatively, we could use a while loop instead. So we can say while index is greater than 0 or greater than equal to 0. And I guess we could set it to the length of in list -1 up here. The thing about a while loop, though, is you need to change the index yourself because it looks like it's got stuck in an endless loop. It's kind of crashed. So we have to remember to decrease index ourselves if you use a while loop. But we want to stop when we find what we're looking for. So we can say while the index is greater than or equal to 0 and found is equal to false, or and not found, that's much better. That's what we want. Because as soon as we found what we want, found is set to true, which means the while loop doesn't increase anymore, or sorry, doesn't decrease anymore, so we can say what we found. Okay, it's not the end of the lesson at the moment, but when it is, I would like you to upload to the VLE for me, please. This is half term 9, Algorithms and Programming 9. Make sure you save your Word document before it's uploaded.